Yeah, good evening. So today we will see a different kind of stuff. Like yesterday we have seen the Flash Hello World, right? So today we will see how each and every part, and we explain what is this, like why we have used this decorator, and what is exactly the decorator means, and why this the special attribute name and main. And then we will see what is the function and why when we can use it as first class objects. So first of all, we will see the special attributes underscore name and underscore main. So it's actually built-in special attributes in Python. So whenever we want to run the script directly, we actually define this kind of line. So what happens is, so when we write multiple, uh, for example, when we are writing a very huge application where there are multiple Python files, and we import all that into this one file, and then we want to run it as a main program file. So we generally we import all the data, like all the functions or methods or the classes from which are written in another Python files, but we actually import them. So we already seen something like this, like a square root, for example, import math or something like that. So whenever we import all that kind of stuff, but we want to run only this file, this is actually we call it as main file, and when there is a script, for example, this is one of the main script. So then if you are running this, so generally this attribute name will be set to main. So it's like a top level execution, we can say. So when we go to top level code environment, so for example, if you see in the name of top level environment, so when we run that file, so it will be mainly in the same file. If we run, it will be the name will set to main. For example, if we are importing config parser, so let's do practical also. Just so I'm enabling Python shell. So now if I just, so here if you see config parser underscore name, so here, so here because we have imported the config parser, so it is actually set to that name, like is set a module's name. Even the same thing applicable for that. But if you want to run the main file where we import all the things, like all the modules, and we want to run only from that main file, so this is the main thing we need to write. So generally maximum of the time, if you see any coding files or any Bitbucket repos where we have uh, few Python projects, so this is the line if you see in the main.py file. So these two are the special attributes. So there are multiple uh, special attributes already defined. So like we have taken a name and a main. So if you see here, told the current name of the module of the Python file being executed. So again, what is main? It's not a technical, not but a special value that signifies top level execution of it's actually not a variable, but it whenever this name equal to main, it executes the code directly in that script. When we are not, we haven't imported that Python file as a module. So, for example, if you see def create, so here we are defining. Sorry, we are defining one function like Python if dot main, and we are calling that function. So whenever we run this script, it will call this function and will print hello script. But whenever we import this script into another script, and we imported and we called it as greet. Now here when we check the name attribute, then it actually changes to this another script. It's not main because the greet function is defined in this main script, like my script. So if I want example, me just so I am just saving. Save. So, so we have saved my script. Now I am writing another the same thing like so here it should be my because I have not given an underscore. So I am and the both files should be in the same location. So because this the function we are calling the main script, the lead function. So it will call the hello script, but when you are printing this name, it will print this plus plus because we have imported my script. So we are not directly executing this script, the main file, but we are executing the module where we have imported. So then also, it is still showing another script. Because we call main script, but when strange. Why the output is not coming up? Okay. Import my script and the name should set to another script, but okay, anyways, this I will be checking once again. So because here it should set to another script. Whatever the name we define, it should script on that. Mm. Yeah. So and then so now so the functions now why we call functions are first class objects is like we can pass the function as an argument into another function. For example, we have defined addition, subtraction, multiply and divide. So here we are defining another function where we are actually giving one argument. It's a function as an argument, and n1 n2 are the variables giving us arguments to the function. So here what we are doing, define calculate cal function, and whatever the function we pass, it will call that function and it will take n1 and n2 objects. So in Python, so this is one of the very important thing in Python. So it's like we can actually treat functions as like any other object. So it's like we can assign them to variables, store them in data structures, pass them as arguments. So this is one of the important element we need to check, and even we can return them from the functions. So we can return function in a function. So the first thing is like so we can assign directly like the function to an hello greet object, and then we can directly so this is the greet function, and we are assigning to say hello greet, and then we are calling this object. Like if you see here, we are actually assign a variable to the function, and we are not calling directly the function name, but we are calling the variable to function which we have assigned. So similarly, as I said, so this is one thing, and then we can actually nested functions like one function inside another function, and we can actually call that function inside the function. For example, if you see here, we are defining outer function, and then we are actually calling I am outer, and then inside that we are defining nested function and print, and we are calling the nested function inside the outer function itself, and then the foremost we are calling the function. So if we just comment it out, so if I see and if I run it, okay, so there should not be any spaces whenever we are creating Python file. So here if you see, because we call add function, so it's like it called 2 plus 3 equal to 5. So inside the function we have called the function, and we call the result. So if we change, it will actually change. For example, I want to change to multiply. If I just, so again 236, and here we are actually thinking the nested function. So we are defining in outer function we are defining I am outer. Inside that we are again defining another function like print I am inner, and here actually we are calling nested function inside the outer function. If you see the indentations, so we are not calling nested function inside the nested function, but we are calling the nested function inside the outer function, and when we are executing we are calling the outer function. So here again it's two concepts again it got matched. So when we can actually pass function to a function, and inside a nested function. Because we are returning a function, so that we will see here. So now if you see here, we are not calling the function, but we are actually returning the function, so without any parentheses. So here what we are doing, we are actually creating one variable, like, and we are assigning the function. Now if we just run this function, it will just execute only this one. But if we, for example, let me just save it and run it. So here it is executing because it is calling only outer function because it's a variable. But if we give this function another like a function type of thing, like a function calling like a function, this variable, then it actually calls both the functions, outer function and inner nested function, inner function. So then we should get both I am outer, I am inner, both we should print, right? So it is printing. So this is little bit confusing. So we have actually, if you want to check, so here, so the same thing here, print I am outer. We are returning the function and we are calling the function. So now when we visualize the execution, so the first it will create an object like outer function object, and then it will go to the definition of the function, so outer function. Now actually it will go to the print statement and it will print the I am out. Now the execution comes to nested function. Because the nested function here, if you see the parent, since we are returning the function, it actually goes to the return statement. So inside the parent f1, we are actually returning the function. Now there is a return value of that function. Now then it actually calling inner function. Now again it is going to the definition of the function. So in the global front there are two functions defined. So there are two objects created. So here its return value is the nested function. So if we just um, if we just calling this function, let's see how the execution will be like. So it's creating outer function, and it created return value. But it haven't gone to this function because we haven't called the exact the inside function, like we haven't called the variable as this function, like variable like a function. So the same thing applies here. So if we create a adder and we are defining a adder like a return x plus y, and then here we are returning a return adder. So the same kind of logic. So we are adding add 5 created. We created one object like, so it's like we are passing x as 5, so add 5, and we are passing again x as 10. So we are creating two objects. Now inside 5 we are actually calling this function, like this adder function it will call. So it's like 5 plus 3 it will be 8, and it's like 10 plus 7 it will be 17. So if we want to check this, let's check this as well, or we can actually check in. So if you see, so 8 and 17 is the outputs. So it has created two functions like adder and then return value, and x equal to, and the adder and the return value. So now again, and the same in the nesting function as we see already, the same thing. So for example, we are define speaking, and we are calling define another function whisper, and then we are actually lowering it, and we are adding some full stops at the end, and we are actually returning the text. Now whenever we call this hello world, the text in whisper, because here we are actually directly returning, because here if you see we are calling two functions and we are returning the function as well, like uh, but in this example we are not returning the function, but we are just returning the name of the function. So the text whatever we pass in the speak, it's returning the whisper. So whisper will get the same text whatever we pass, and then it will go to this function definition, and it returns, uh, it will lower all the strings, all the characters in that string whatever we pass, and it will add this full stops. So the output will be something like this. So again, so it got text, and it's like the whisper is the function it called, and it's the same text we are passing, and then it is actual return value is the hello. So now uh, so why we are learning all this, because we extensively use this kind of nested function in the Flask, and And then the decorators are nothing but one of the example is the same nested function we define. So now the decorators are something similar kind of stuff where we do uh, the nested kind of stuff where we call two functions and we define, and we actually use that kind of notations uh, to integrate some of the behavior in the another function. So it's like if you see modify the function method without permanently altering the original code. So for example, if you want to add logging loggers to your code, it is one of the example. Or if you want to delay some time, so we will see that both examples here. So generally there will be decorator function, and inside that there will be wrapping function. So in that wrapping function where we actually order the code. So and we call it as like at the rate symbol, where we use already we have used like at the rate app the decorator in the Flask framework. So the wrapper function is one of the main functions. So whenever we call that at the rate, and it actually call the decorator function, and then it calls the wrapper function inside that. So let's see with example. For example, let us take this example and let's view in this. So now it actually directly it goes to the execution. So before that we can see here we have defined a log function. So and we are passing a function as an argument. So it is a decorator function. So now inside that decorator function we have a wrapper function. So here whatever the function we pass, it actually suggests the name. We already see this name attribute, and here result is what are the position arguments or keyword arguments it is passing, and then function, and it is returning the result like wrap function, and we are returning the wrap. So next step, it goes to the function definition. So there is no keyword arguments, only there is no positional arguments. So if you see, it's 0, 1 are the positions in a tuple. So now it calling the function dot name, whatever we call it to find the function. So what are the function is you see the result. So we are returning the result. So this is one kind of decorator function. Now we will see the another kind of decorator function. So now here we are defining another decorator. So it's a function. We're defining a wrapper function. So in the wrapper, so we want it to wait for some time. So this is one of the something before the function we call the exact function. And now it is like we have calling two times, so it will print two times. And even after calling, if you want to do something, we can also do something. So if I just comment it out, so now we are calling this. So if I just comment everything, right. So if you see, it has waited for 2 seconds because we haven't called that. So again, if I just so now it will print two times after 2 seconds. So now if I just comment this out, it immediately prints. So it haven't waited because we haven't set the time to wait. So here we have called the function. So the decorator is automatically added 2 seconds of sleep, like 2 seconds of wait time, because we have said that it's a delay decorator. So again the same thing. So this is called syntactic sugar. So when we can directly call it as like this at the rate notation is called syntactic sugar. So now if I just both are same. So if we want to run without that at the rate notation, like so now there is one thing. So value, so decorated function. So the same thing what we already done, uh, what you already seen. So delay decorator. So we are calling that function, and we are saying this. We are passing this say greeting to that function, and we are calling decorated function. So that it will call this wrapped function. So now if I just run. So because we are calling two functions here, we haven't called the say by function. So that's why we it haven't printed by. But it has waited for 2 seconds, right? 2 seconds, hello, and then it has uh, printed how are you. So this is the notation is equal to this notation. So now going back, so here this is something where I meant to say already the notation where there is a decorator already defined, and then we are actually pointing it to this first slash is like the root directory. Now if I just so now if I run this, so here what I am doing, I am creating another function, and then I have rooted the other thing. So it is like there are multiple pages, right? So it's like google.com, for example. Again we have seen, for example, this is the main root, but if you want to render, or if you want for example this one replit, so now this is the main directory, but if you want to go to this page, then how we are doing. So similarly now if I just run this, sorry, so because it's a URL, right? URL should start with so 727.0. So here it is doing but when I type by, so here it is printing by, if you see. So this is how we are rerouting the URLs, like whenever we want to link multiple pages on a single website. So this is how the Python decorator will help us. So here the routing in the Flask framework, this is the main thing we use for routing all the pages or all the URLs. So this is the decorator, how the decorators is defined as of we seen now, right? So this is how the decorators are defined. So this is the explanation. So the same thing. So we haven't changed anything today. Just we have added one more function, and we are rerouting using the decorator, and it with the same attributes, name equal to main, and then we are running. the Flash web server. Just quit now. Quit. Yeah. Yeah, that's it for today. Thank you.